So here you have another real life function of a graph. The car passes a point P after which its speed, so speed is V or velocity, okay? So V is equal to velocity or speed, okay? Which is the same as speed, so just in case you're wondering there, right? It's given by this function. So V is equal to 15 minus 3 times t, where t is the time in seconds. So you want to draw a graph of V for 0 to 5. So V, when t is 0, V will be equal to 15 minus 3 times 0, which is 15 takes 0 is 15. So 0, 15. When t is 1, V is 15 minus 3 times 1, which is 12. So 1, 12. When time is 2 seconds, the velocity or speed is 15 minus 3 times 2, which is 9. So 2 and 9. When t is 3, V is equal to 15 minus 3 times 3, which is 6. So 3, 6 will be the point on the graph. When t is 4, V is equal to 15 minus 3 times 4, which is 3. And finally, when t is 5, the velocity is 15 minus 3 times 5, which is 0. So 5, 0. So it's these points here that we're going to use to draw our graph on our x and our y axis again, except even though it's an x and a y axis, it'll be in decline mode, so it'll be going down, okay? And these are going to be our time in seconds. So from 0 to 5, 0, 1, 2, 3, 4, and 5. So be as neat as you can, and that's t, or x-axis, okay? And then on this axis, we're going to put v, so velocity or speed, okay? And we need to get up as far as 15. So 2, 4, 6, 8, 10, 12, 14, 16, okay? And this is our y-axis or v-axis, okay? Just because the question talks about t and v, all right? So when t is 0, the speed is 15. So 15, 0 up to 15. When t is 1, the speed is 12. When t is 2, the speed is 9. When t is 3, the speed is 6. When t is 4, the speed is 3. 3 is between 2 and 4. And finally, when t is 5, the speed is 0. So when I join these then, again, I get a straight line graph, okay? So it's what you would have expected anyway. And now for the questions. So what's the speed of the car at t equal to 3? So we have to use our graph at t equal to 2.3. So 2.3, 2.6, right, so I'm going to say 2.3 is roughly about here. So it's an estimate. So part 1, that's part 1. If this t is equal to 2.3, v is equal to 8, and it's meters per second going down. So hence the minus 1, right? It's going downhill, downslope, okay? Now for part 2. The time at which the speed is 10. So use your estimate again. So go to 10 on the speed and work down to the time axis. So that's part 2. And I would say 10 is 1.6 seconds. So I'm using a different colour to help you out here, okay? And finally, the speed of the car as it passes P. So what's the speed of the car as it passes the point P? Okay? Well, where is the point P? Car passes a point P, after which a speed is given by this function. Okay? So what's the speed of the car at point P? P is equal to 15 meters per second. So we're only recording the graph from here. So this is where the speed is 15. Okay? Now, how long does it take the car to stop? Well, the speed is going down, look. So 15 meters per second, 14, 13, 12. So the car is eventually coming to a stop. And how long does it take the car to stop? Well, from 0 to 5 seconds. So part 4, it takes 5 seconds for car to stop. Okay? And that's how you go about answering that functions question. Alright? Now, that's question 5 for you.